So hello everyone. Let's start the discussion for biweekly contest 172. So let's move to the first problem. The very first problem says that we are given a integer array nums. In one operation, we can remove the first three elements of current array. If there are fewer than three elements remaining, all the remaining elements should be removed. Repeat this operation until the array is empty or contains no duplicate values. Okay.
Um, Mic test. Hello.
Hello. Hey, hello. It's a mic test. Okay. So let's start with the discussion. So the very first problem says that we are given an integer array, say nums. In one operation, we can remove the first three elements of the current array. If there are fewer than three elements, all the elements need to be removed. Now repeat this process until array is empty or contains no duplicate values. Return an integer denoting the number of operations required. Okay, so what does the problem statement say? For example, we have this array given to us. Now we need to do the given operation until and unless the array is empty or is free of duplicate values. Is there a duplicate value in this array? The 3 in the first index is also present on the third index. So it is a duplicate value. Alright. Duplicate value is are values that are present multiple times. Now we need to get rid of this. And how to get rid of that? Just do the operation. What does the operation say? Operation says to remove the first three elements unless and until the duplicate value condition is satisfied. So in the first operation, the very first operation which we apply, we are remaining the first three elements from our array. We are removing this, so the array becomes 658. Now, is there a duplicate element? No, it's not present. So this is our answer. What do we need to return? We need to return the number of operations that we have applied on our array. So how many operations we needed to apply? It is 1. Now in this example, the array is 2, 2. All right. So Is there a duplicate element? Yes, 2 is present 2 times. So apply the operation. What does the operation say? Remove the first 3 element, or if there are fewer than 3 elements, remove all the elements. So removing all the elements, our array is empty. An empty array is always a good array. That is, it is free of duplicates, and we need not apply any more operation. How many operation we needed to apply? One operation. So the answer is 1. Now in this array, is there a duplicate value? 1 is present 1 times, 2 is present 1 times, 3 is present 1 times, 4 is present 1 times, and 5 is present 1 times. So no duplicate value means no operation need to be applied. Alright. So the answer should be 0, and it is 0. So what do we need to do? Uh, Applying the operation, what do we do? Just iterate over the first 3 elements and remove them. So applying is easy and can be done in O of n. A single operation needs three computations to be applied. Okay, so it is approximately O of 1, and at max how many operation can we apply? It is n by 3. After that the array will be empty. So applying an operation is pretty much computable. It is pretty much O of n. Alright. But what this O notation denote? It denote the number of operations or computations that the machine need to do. This plus, multiplied, minus, all these are one computation or one computation which the machine does. So uh, applying operation is approximately doing n calculations. All right. Now coming to the second part. Second part is checking whether array is free of duplicates or not. The checking part, what do we need to do? We need to iterate over all the sets of elements present to us and check its count after every operation. So it would be O of n again. And if we do this after applying all the operations, okay, after applying each operation, we are checking that if our array is free of duplicate values or not. It would be n into n, which is not computable in the scenario given to us. So we need to do some optimization here. So what optimization can we do? Complexity. All right. Is it working? Yes, it is. Okay. So checking also takes O of n if we do it after each operation. So we need to do some clever optimization. What is our optimization? We can maintain the count of count of duplicate elements. Okay. Initially, let's say our array had in this scenario. Okay. In this scenario, our array had one duplicate element, which is 2. All right. So we needed to apply one operation. And if we had a count of that value, that is how many duplicate elements are there, after applying one operation, we can just see that, okay, we have removed 2 and 2 was a duplicate element. So the count of duplicate elements has reduced by 1. And at the end, when our count goes to 0, that is our answer. So apply operation until count is greater than 0. All right. And at the point the count is 0, we just need to return uh, the number of operations we have applied until now. So let's move to the implementation part of this code. Okay, so let's move to the implementation part. What do we need? Initial. Okay. Okay, so let's move forward. What do we need? We need the count of duplicate elements. So iterate over all the elements of. Hello, it's a test. Yeah, okay, so let's move forward. Really sorry for the disturbances caused. Okay, so we iterate over every element of the map, and if the current value has a frequency greater than 1, it is a duplicate element, right? So increase the counter by 1. Now we need to have an answer which denotes the number of operations applied. Now start applying the operations. Where do we start from? We start from the 0th index. After applying the first operation, we move to the third index and so on. So till which value do we move? We move till nums dot size, okay, till the size of this particular value or this particular array. And do we need add one? No. In one operation, we switch by 3 indices. So we add 3. Now, if the current index is valid, then we apply the below operation. We say decrement the counter of current element by 1. And if after decrementing, we get to know that the current element's frequency is equal to 1. That is, there were 2 elements present before this decrement. Alright. So there was a duplicate element present. This particular current value was contributing to a duplicate element. But now, since its frequency become 1, so it is not at all uh, contributing as a duplicate element. So decrement the counter by 1. Now similarly, we will apply operation on the next index. Just the same thing. Hey, hello. Hello, hello. Really sorry for the disturbances. So we had done the very first problem approximately. What did we do? Let me communicate it again in case uh, we just missed out somewhere. So what did we do? We started and calculated the count of duplicate elements. All right. So we created a map, and for all those values which are having frequency greater than 1, we just incremented the counter by 1. That is, it gives us the count of uh, duplicate elements present. Now start applying the operation. In one operation, we apply operation on current index, index plus 1, and index plus 2, because 3 elements are to be chosen in every operation. And after each operation, increment the starting element by 3. All right. And keep applying this operation until and unless the value of CT is greater than 0. That is, there is an element, duplicate element present in our array. And after each operation, increment the number of operation applied by 1. At the end, return the number of operations applied. Okay. So now let's move to the second problem. Okay, so let's move to the next problem now. The next problem says that we are given an integer array nums. Our task is to choose exactly 3 integer from nums such that the sum is divisible by 3, and return the maximum possible sum of such a triplet. Or okay, like we have this array. Like we have this particular array. Now, what are the number of pairs that gives us the sum which is divisible by 3? Uh, and we do not need pairs, we need triplets. What are the possible triplets? These are 4, 2, 3, then 4, 3, 1, and 2, 3, 1. These are the possible triplets. All right. The first triplet, what is the sum? Sum is 4, 5, 6, 7, 8, 9, which is divisible by 3. So it is all right. The second one is 4 plus 3, which is 7, plus 1, 8. And the third one is 2 plus 3, 5 plus 1, which is 6. Alright, so what are the values that are divisible by 3? 9 is divisible by 3 and 6 is divisible by 3. What does the problem say to us? Problem say that we need the maximum possible sum. And what is the maximum possible sum? It is equal to 9. Okay. Okay. So we need to return 9 in this case. Now in the second scenario, we are given array of 3 length. It is 2, 1, 5. What is the sum? 2 plus 1, 3 plus 5, 8. And 8 is not divisible by 3. So the answer is 0 in this case. So how to approach this problem? Because creating all the possible triplets is n cube and the value of n is 1e5. So it is not possible. Instead of thinking about the triplets after summing up, like that, considering the actual value of triplets, that is considering the value 4 as 4 itself, consider the value as 4 modulo 3. What is 4 modulo 3? It is 1. Let's discuss about the modulo operations in this scenario. What is happening and what can happen? What are the all the possible modulos? Because if a number is divided by 3, it will give a reminder either 0, either 1 or either 2. Alright. So if a number is divided by 3, modulo or reminder is 0, 1 or 2. Alright. So can we do something using this observation? If all the 3 numbers give reminder as 0, then the final reminder would be 0 again. And one property which you should know before approaching this problem, like if we are doing this a plus b plus c, then modulo 3, it is equivalent to do the modulo thing first. A modulo 3 plus b modulo 3 plus c modulo 3, and at the end do a modulo once again. Alright, this is very much similar. So we take use of this particular property to solve this problem. Because we know that value of a modulo 3 is between 0, 1 and 2. Similarly, b modulo 3 is between 0, 1 and 2. So we check for all the scenarios. So let's say all the numbers a, b and c have modulo 0. Then the final modulo will be 0. And we know that 0 modulo means that the current number will be divisible by 3. So it is a good scenario for us. Now let's consider another scenario, 0, 0 and 1. What do this give? This gives the modulo as 1. So it is not a good scenario. That is, it is bad because such sum will give us modulo 1. And modulo 1 means that number is not divisible by 3. So that triplet is not valid. So let's try to find out all the triplets that are valid. So we see that 0, 0, 1 is not valid. Now 0, 0, 2 is also not valid because sum is 2. Now what about 0, 1? Now if we have chosen 0 and we have 1, to make the reminder 0 again, sum should be a multiple of 3. And how can we make it a multiple of 3? We have only 3 choices, 0, 1 or 2. So if we add 0 again, the sum will be 1. If we add 1 again, the sum will be 2. And if we add 2 again, the sum will be 3. And taking the modulo with 3 again, this modulo with 3 again, which formula just I stated above, we get modulo as 0, and it is also a good scenario for us. Now what about we take 0, 2 and then 1, or then 0 or later 0, then it is also not a good scenario for us because sum is 2. If we take 1, then it is same scenario as above. uh, the second number is 1 and third number is 2 here, and here the third number is 2 and second number is, sorry, second number is 2 and third number is 1. So we are not considering order for now. Let's not consider order for now. So no possible scenario is left over with us. Now think about choosing 1. If we choose 1, then what if we choose 1 again? Then if we choose 0, sum is 2. If we choose 1, sum is 3, which is 0 when modulo 3 is taken. So it is a good scenario for us. If we had taken 2, then it is also not a good scenario for us, because the sum is equal to 1 again. So the total sum would be 4, and if we take modulo with 3, it would be 1 again. Now, uh, and another scenario, 1 1 2 is over, then 1 2 1, it will be repetitive scenario, uh, and it is not a valid scenario as well, and 1 2 2 is also not a valid scenario. Now starting with 1, just keep in mind that order do not matter here. If that particular permutation has already been counted, no need of counting it again. Now starting with 2, if we choose any number smaller than 2, then that has already been considered, all right, because order does not matter. So we have only one scenario, 2 2 2. And what is the sum of 2 2 2? It is 6. Take modulo with 3, it is 0 again. So these are the possible scenarios which can give us sum that is divisible by 3, all right. Now we want maximum sum, and we know that these are the possible scenarios with us. So if we want the maximum sum where the first number is divisible by 3, that is first number modulo 3 is 0, second number modulo 3 is 0, third number modulo 3 is 0. So keep a, for this, keep a track of all the numbers which give modulo 0 with 3, all right, and arrange them in sorted order. Let's say descending order, that is decreasing order. What will happen in this scenario? If we pick up the first three numbers, those will be giving us the maximum sum. Okay, because we had many choices of choosing the numbers of with 0 0 0. If we choose the maximum values, that will be the criteria for giving us the maximum sum, right? So choose the maximum three values, or the first three values in sorted order, in the descending order. Three values as a contender for answer. All right. Now for 0 1 2, keep a track of all the numbers which when taken modulo with 3 gives 0 1 and 2, all right, and sort them again. Choose the very first element, that is the largest elements from all these three scenarios, all right, and choose that as a contender again. Similarly for 1 1 1, uh, keep a track of all the numbers that gives modulo 1 with 3 and choose the largest three values. Similarly for 2, and among all these contenders, the value that gives us the maximum sum, that will be our answer. Okay, and that is what we will return. So let's move to the implementation part. This was all about the logical part. So how can we implement this? Let's move forward. Okay, so what do we need? We need to keep track of all values that gives modulo x. What do x mean? 0 1 or 2 with 3. Alright, so what is the value of x? It can be 0, 1 or 2. So we are maintaining a vector of size 3. Let's name it as track or vec, let's say. Alright, for keeping a track. Now iterate all the numbers. While iterating over all the numbers, check if the current value modulo what it gives. If it gives 1, 0 or 2, that is the value of x, and insert this number in that particular index of vec. Alright, so vec of 0 gives us track of all numbers that give modulo 0 with 3. Alright. Similarly, vec of x gives track of all numbers that gives modulo x with 3. Now just push this particular element inside the vector. We need to sort in descending order all the three vectors or track arrays we have created. To sort in descending order, just use reverse begin. Alright, R begin. Now we need to do the same thing for the vector with modulo 0, modulo 1 and modulo 2. Alright, this is it. Now create a answer value. What does this answer say? Answer gives us the maximum among all the contenders. Alright, now iterate over all the possible contenders. The first contender was 0, 0, 0. So if vec at 0 dot size is greater than equal to 3, because we need at least 3 elements to have a scenario of 0, 0, 0. Alright, then answer is max of answer comma vec at 0, 0 plus vec at 0, 1 plus vec at 0, 2. Alright, now the second scenario. In the second scenario, we have 1, 0, 1, 1 and 1, 2. So every vector 0, 1 and 2 should have at least one elements. If all of them have at least one element, answer is max of vec at 0, 0 plus vec at 1, 0. We are picking up the largest element from all these three tracks. Alright, now the fourth scenario, we had 1, 1, 1. Okay, third scenario, we had 1, 1, 1 and fourth scenario, we had 2, 2, 2. Just copy paste the first scenario we had. We were checking for 0, now we are checking for 1, 1, 0, 1, 1 and 1, 2. That is the largest element of track 1, the second largest element of track 1 and the third largest element of track 1. Similarly, the largest element of track 2, second largest element of track 2 and third largest value of track 2. Among them, the maximum answer, that maximum contender is maintained inside the answer value, answer variable. So return that answer variable. And that is it for this problem. Now let's move forward to the third problem of today's contest. So in this problem, we were given Okay, so let's move to the third problem statement now. The third problem says is that we are given a integer array nums of length n and a binary string of same size. All right. Initially, our score is 0 and each index I where s at I is equal to 1, that is the string contains one value at that particular index, contributes num I to the score, that is the index 1 in this particular string. Let me zoom in. In this particular string, the index 2 is having value 1. So the corresponding index in nums, that is index 1, which has value 1, will contribute uh, that much value to the score. Now we have some operations that we can apply. We can swap two characters if the string at some index is 0 and the next index is 1. Alright, if we get this scenario. I think the whiteboard is not working. Okay, it is fine. So what do the problem say? Problem say that let's say we have this string. Now we need to find substring of size 2, which is 0, 1. Now we can swap these two indices, that is 0, 1 can be converted to 1, 0. Alright. So note down some observation with this operation. What do we observe from this? If the left index is 0 and the right index is 1, then a operation can be performed and this 1 can be shifted one leftward. Alright. But is there a possible scenario in which a particular 1 value can move to its right? I don't think so. No. Because there is no particular scenario in which left is the smaller index, that is 1 is the smaller index and the operation can be performed. So value 1 can only move leftwards. This is the observation, first observation. Okay, now apart from this, is there any constraint on the string, final string to be formed? So for this, let's try to have a construction. If we can uh, come up to a construction where this particular scenario is satisfied, that is in the final construction, all the final ones are present to the leftward of their initial value, then we can say that all the possible values which satisfies this particular constraint can be framed with this operation. Let's say our initial string was 0, 0, 0, 0, 0, 1, 0, something like this, and we want how many number of ones are there? 1, 2, 3, 4, 5. So we have 5 ones here. So what is happening? This one is shifted here, this one is shifted here, this one is shifted here, and these two ones are shifted here. Is such a construction possible? I would say yes, it is. And firstly, check that if it follows the first constraint. Yes, all the ones, final indices of ones are present to the left of their initial value. So this particular constraint is satisfied. Now, how can we frame this string from this string? Okay, and start applying. Okay, hello. Okay, so let's move forward. So where were we? We were at implementation phase. So start iterating from right to left. If you see a 1, then pick a number. Okay, and this number corresponds to this one now. Move to left. That is, pick the current number. Okay. What if we see a 0? Then obviously we cannot pick a number now because there is no one corresponding to it at the current index. Now we can have a one corresponding to it at a later index. All right. So what can we do for it? If we have already chosen a number that is smaller than the current number, it is wiser to refuse that element and pick up the current element. So from the list of chosen number, pick the smallest number with current number. All right. So the one that was corresponding to the smallest number is now corresponding to the current number, and this construction is valid as well. And later on, when our iteration is finished, remove or return the sum of that list and pick up this current number in a list. All right. Return sum of list. So this is it. What do we need now? We need a list or data structure to store a number, and that data structure should also give us the smallest number among all the chosen numbers. All right. So a very perfect data structure for this is set or min heap priority queue. Sometimes priority queue is faster than set, so we will move forward with the priority queue approach. So let's just implement what I wrote here. That is it. Now let's start with the implementation. So we need to have a priority queue. It would be better if you learn the syntax of priority queue because it is little complex. So the first uh, input is the type of data type you will store inside the priority queue. The second is just a simple vector int, that is what type of data structure or uh, storage format it will follow. And the second is the comparator operator. In the comparator, we write greater int. Greater int just sorts in uh, ascending order. All right. Normally priority queue follows descending order format. That is no, the normal priority queue, if we had just written int here, then it would be a max heap priority queue. That is, on calling the top element, the biggest element would come up. But if we write the comparator as greater than, the smallest element would come up. All right. Sorry. So iterate over the string from end to start. Now, if the current value of string is 1, what did we decided? We decided to insert this element inside our list. So pq.push num set I. All right. And in the second scenario, when the string is 0, if our priority queue is not empty, all right, we have some number to replace. Uh, then we need to check once again if the top element is smaller than the current element. Otherwise, it won't be wise to replace it. All right, because we want to maximize the sum. So have the maximum elements so that the sum is also maximum. If the priority queue top element is smaller, then pop it and push the current element. So the one that was corresponding to the topmost element now corresponds to the current element. All right. Now at the end, we want the sum. So long answer. While our priority queue is not empty, just sum up the top element and pop the largest element. At the end, return answer. This is it. Let's move forward to the next problem. So this is the final problem for today's LeetCode. In this problem, we are said that we are given an integer n. We write the integers from 1 to n in sequence from left to right. Then alternatively apply the following two operations until one integer remains, starting with operation 1. Okay, what do operation 1 say? Starting with from the left, delete every second number. So this is the list 1 to 8. Delete every second number. That is delete 2, 4, 6, and 8. Down the list concatenates with the remaining elements. So it becomes 1, 3, 5, 7. All right. Now again apply operation 2. Operation 2 says that remove every second element starting from right. All right. So in this leftover list, starting from right, choose all the second elements. 5 is a second element, then 1 is second element. Okay, jump from 7, 1 index, then 2, 2 index. All right. So 5 and 1 are removed. So the leftover array is 3, 7. Now alternatively apply the operations. That is, this is the turn of operation 1. So the second element starting from left. So 5 is removed and 1 is left. At the end, the array consists of only one element. So it is the answer. We need to return 1 now. Okay, so let's move to some of the observations involved in this problem. Okay, so the first observation is the constraint. What is the constraint? The constraint of n is 1e 15. This gives us the idea that either O of n solution will be O of one solution will be accepted, or O of log n solution will be accepted. All right. So binary search is a very good consideration for this scenario. All right. Now the second scenario. How many operations can be applied? Okay. How many operations do we need to apply in order to uh, reduce the size of current array to 1? Let's say we had 1, 2, Okay, let's say we had 8 elements. After the first operation, how many elements are removed? Okay, because n is okay, so it would be better if we consider 9. After 9, how many elements would be removed? 2 will be removed, 4 will be removed, 6 will be removed, and 8 will be removed. So n by 2 elements, that is 4 elements removed. Now what is the number? 5. 5 elements remain. Now from 5 again, how many elements will be removed? We have 5 elements and every second element is removed. So the second element, the fourth element. So 2 elements. Okay, 5. 1, 2, 2 will be removed. 3, 4, 4 will be removed, and 5. Right? Okay, just write it down for better understanding. We have n is equal to 8. All right. After one operation, what elements will be removed? So 2 will be removed, 3 will remain, uh, 4 will be removed, 5 will remain, 6 will be removed, 7 will remain, and that is it. All right. After second operation, what will be removed? 5 and 1 will be removed. So 3, comma 7. But still, we do not have an odd number here. We get to know that if the number of elements are even, if the number of elements are even, then n by 2 elements are removed. And the new size is n by 2 again. Okay. Now, if the number of elements are odd, for example, 1, 2, 3, 4, 5. All right. If we have 1, 2, 3, 4, 5, then 2 and 4 will be removed. So remaining elements are 1, 3, and 5. So n by 2, that is taking floor, elements are removed, and n plus n by 2 seal remains. What is the other way to write seal? N plus 1 by 2 for 2. All right. There is a very good formula if you want to know. If you want seal of n by k, then write it as n plus k minus 1 by k. Here k is 2. So put it here. 2 minus 1 is plus 1. So n plus 1 by 2. All right. So write down all the observations. The first observation is after operation, n plus 1 by 2 elements remains, and n by 2 elements are removed. All right. Because this particular thing gives same answer with even, that is floor and seal will be same if n is even. All right. So this particular formula works for both odd and even scenario. Now now we were considering the count of number of operations required to uh, convert the size of our array to 1. All right. If you note it down, after each operation, the size is divided by 2. All right. Now, if we keep dividing a number by 2. If you have studied bitwise operation in a detailed manner, then a right shift means dividing an element by 2. All right. Although here right shift denotes floor operation, but here we are considering seal operation. And these both are pretty much similar, all right, because there is a difference of only one element. So the O operation, that is considering the equivalent number of operations, would be same for both of the scenarios. Now, this would give is it this particular operation is very much similar to dividing by 2, and we know that 10 to the power 15 consists of around 60 bits. All right. So how many right shift operations can we apply to 10 to the power 15? At most 60 operation. So we can say that in this particular thing is equivalent to 2 to the power 60. All right. In at max 60 operations, we can reduce our array to a size of 1. All right. Let's move forward now. Write this observation in the lists of observations we have made. In at max 60 operations, we can reduce the size of array to 1. All right. So try to find one thing. We had already in our mind that binary search can be applied here because login would always work. So try to frame some predicate, just framing some random predicate. The first idea that comes up is for a index I and number of operations k, will it be surviving? Okay, will there be any number to the left of it that has not been removed? Okay, just a random idea of predicate. All right. For intuition, if you have had solved similar problems of binary search, it would have hit you. All right. So using this predicate, can we write our answer? So after 60 operations, let's say it takes k operations to completely convert our array to an array of single length. All right. So let's say this is our answer. That is, this is the index. Let's say 6 is the index which is left after k operations. Then if we can frame such a predicate, then that predicate would give answer 0 with k operations for all the indices that are present to the left of 6, and for all the indices that are present to the right of 6, the predicate would be giving 1. Why? Because the predicate checks if there is at least one index to the left of this particular index that is left after applying k operations. Now a big question in our mind. Okay, so about solution, if we can find such a k, that is we can find that predicate, then the first index where this predicate gives answer as 1, that will be our answer. All right. And that can be done very easily using binary search. But still, this predicate is a big question for us. How to calculate this predicate? and we have too much observations to solve this particular predicate. How to do it? Let's see. Okay, so we are considering a index I. Okay, let's say initially how many elements are present to the left of I. These are uh, I elements, that is prefix of I contains all the values from 1 to I. So I elements are present to the left of it. After first operation, how many elements will be removed? It will be equal to how many elements will be removed. All right, not remaining. Okay, we are interested in number of remaining elements. Okay, so how many elements remains? It is n plus 1 by 2. Okay, after first operation, n plus 1 by 2 elements remain. After second operation, okay, so we had some 1, 2, 3 dot 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 up till I, and then n minus 1, n minus 2, and n, let's say. Okay, so for this prefix we have the formula, that is after the first operation n plus 1 by 2 elements remain. But in the case of second operation, the operation is not applied in the from the left of it, that is the prefix won't be a consideration right now. The new prefix would be the suffix of current array. All right, because we are seeing the array from right and then applying the operation, so the formula will be valid if we start from right. Okay, so no problem. uh, we want to find number of elements removed from prefix I. All right, now we can find the number of elements removed from suffix using this formula itself. Okay, we want to find the number of element remain, and to find the number of element remained, we can find the number of elements removed and subtract that from the current element. So this gives us the number of remaining elements. So our current intention is to find the number of elements removed. Now this is equal to total number of elements removed. Okay, so we know the size of array currently. Okay, and if we just apply this formula n by 2, then we can find the total number of elements removed. And if we subtract the number of elements removed from suffix I plus 1, okay, from this suffix how many elements are removed, that is equal to the size of that suffix. How can we get the size? N minus I. This gives us the size n minus I. And how many elements are removed? It is equal to n by 2, which we calculated above. Okay, this gives us number of elements removed in suffix, and if we subtract it from number of elements removed in the overall array, okay, this gives us number of elements removed from prefix I, and we can still count the number of remaining elements. And at the end, after applying k operations, k is the number of operations needed to convert our array to 1. If after k operation the prefix has one value at least, one value left, return 1, else return 0. All right, this is it. Let's move to the implementation part. Everything required is written right here. uh, and we use the observation which we stated first to come to our conclusion. All right, so let's move to the implementation. We will just implement the same thing as discussed. Okay, First, we need to count the value of k. K is number of operations applied. Let's denote it as OPN. Now we need a temporary value which will be assigned to n and just simulate the process until and unless the size of the array is 1. One more operation need to be applied and the new size will be temp plus 1 by 2, that is seal. Number of remaining elements as we discussed earlier. Now we need to create a predicate. Create a predicate using lambda function. What do we need in input? We need a number, or let's say index. We denote index by num. Now this predicate will return if there will be a number present to the left of to the in the prefix of this num that will be remaining after applying k operations. So we won't try to harm this num variable because we would be needing it later. So write it as n. Okay. This n is the input array. Okay, total number of values currently present, and create another variable with name sm. Sm denotes the smaller than elements. Okay, smaller than the current index. That is the number of elements smaller than the current index that are present is denoted by sm. Initially, what's it values? What will it be? It will be equal to num itself. All right, because array is 1, 2, 3, 4, 5, 6, 7, 8. We have num as 5. So how many elements are present to the left of it? It is equal to the number itself. All right. Now start applying the operation from first operation to the last operation. In the first operation, that is all the operation where I is odd, operation will be applied from left. All right, so it is very simple. We just calculated that the length will be changed by the uh, seal value with 2. All right, and same with sm. But the problem is with scenarios where I is even, because operation will be applied from right. So what is the total number of values that are removed? The total is removed elements is simply cur by 2. All right, because floor is the number of elements that are removed. All right, now how many? Okay, how many elements are present to the right of this particular element? That is, how many elements are present in the suffix of I plus 1? That is equal to n minus I. It is denoted by extra. That is, these are the extra values that is present in suffix. It is cur. That is total number of elements minus total number of present elements present in prefix. We want the number of elements present in suffix. It will be equal to total number of elements, which is cur, minus total number of elements present in prefix, which is sm. All right. Now, what is the new value of sm? It will be number of elements removed. What will be the number of elements removed? The total number of elements removed minus number of elements removed in suffix. All right. And what is the number of elements removed denoted by? It is denoted by seal value. All right. Now, what about cur? Cur is pretty much simple. Cur is the total number of length of the array. If we see it from left or we see it from right, the answer is same. It will be equal to the uh, what is it, seal value itself. Now at the end, after all these processes have been or operations have been applied, if there is at least one element present to the left of sm, then or to the left of num, then sm value will be greater than equal to 1. then return 0, return 1, else return 0. Now just we need to write the binary search where we find the very first 1 in our predicate. So for that, low will be equal to 1 because the minimum possible answer is 1 and maximum possible answer is n. Now write down the template for binary search. Pretty much simple. If OK of mid, then high equals to mid, else low equals to mid plus 1. Alright. At the end, if low itself satisfies, that is OK of low, then high equals to low. At the end, return high. That is it. This gives us the correct answer. That is it for today's discussion. We will be meeting soon tomorrow for the discussion of weekly contest.